The hyperbola definition is a set of the all points in the plane that the differences subtraction between whose distance from the two fixed points positive is a positive quantity, positive constant 2a. Okay, the part of the hyperbola. Hyperbola have different parts you have to remember. Transverse axis, okay, is the axis in which open the hyperbola. Conjugate axis, perpendicular axis to the transversal always. Vertex is the point when the hyperbola crosses the transversal axis. Focus always lie in the transversal axis. Center is the center in which open the two branches of the hyperbola. And asymptote, you have two asymptotes. Oblique asymptote. Okay, this is equations. This is equation. This is a set of equations of the hyperbola. Okay. Very important. This equation first. This equation, you see, A is different to the ellipse. In the ellipse, A is the bigger. No. And the hyperbola, no. And the hyperbola, A is the coefficient associated with the positive part of the equation. Look, A is always the positive. But the problem is when the A is associated with the X, when the X is the positive part, the transversal axis is or on the x-axis or parallel to the x-axis. In this case, no, it's another kind of hyperbola. Okay, the transversal axis lie on the y or parallel to the y-axis. And this is similar, exactly the same, except then this is the hyperbola when the center of the hyperbola is located at the point h, k. Okay? Okay, this is the idea for the definition of the hyperbola. In the hyperbola we have two vertices. This is red point. Two focus, this is the blue point. And the distance d1, d2, when you're subtracting, give me one number always constant. Okay, you have two branches of the hyperbola. In this case, the transversal axis lie on the x-axis, and the conjugate axis lie in the perpendicular against y-axis. Okay, this is the idea for the definition for the hyperbola. Okay, now you can see more clear. This is the horizontal hyperbola, two branch. We have here the transversal axis on the x-axis, the conjugate axis perpendicular. We have the vertex I call h1, h2. You have the focus, que is here, that point and that point, focus. The focus in plural. Now, important, it's very important. We have two oblique asymptotes. To control this oblique asymptote in this kind of the hyperbola, you consider this reference rectangle. In this reference rectangle, this dimension is A, this dimension is A, this dimension is B, this dimension is B. And the slope of this line is B divided by A. I'm passing through the point, in this case 0,0, but not always is 0,0, depending on the value of the h and k. Okay, suppose I move A. Look. Wow. I move B. Wow. I move H. It's horizontal shift. Okay. I move K. Vertical shift. Okay, this is the idea of the horizontal hyperbola. Okay, this is the vertical hyperbola. What is the difference? Well, the difference is clear. The transversal axis now is on the y-axis or parallel to the y-axis. Okay, this is the first important idea. This point and this point is a vertex, center, foci, and reference rectangle is different, a little bit different. This dimension is to B, this dimension is to A. That is the reason that the slope of the asymptote is A over B, not B over A like another horizontal. And the vertical is A over B. Okay, let's see, for example, when you change A, what happened? When you change B, what happened? When you change H, center, change, move with the center. Okay, and K, move it up or down, depending on the sign, see positive. Positive up, negative down. Let's see example now to understand very well the hyperbola.